Good morning, everybody. Today we're going to be going over what's called a phase shift, and it's one of the last topics of graphing sine and cosine. I'm going to briefly go over another portion that you'll need for tomorrow, but today we're basically just going through probably the hardest part of these, besides finding the period and using the period when you're graphing. But putting these two things together is probably the most difficult part of graphing trig functions. So that thing is called the phase shift, and a phase shift is basically horizontal shifts. So you'll remember that horizontal movement is the hardest thing for me to think of because it's usually the opposite of what's going on. Same thing with phase shift. It's a horizontal movement. So it's just, you have to think about it more, or at least I do. And this one you definitely have to think about more because there's a little nuance to it with the phase shift and the period all at once. So just bringing it all together at one time makes it kind of, you just have to you have to go slow and think about it. But the phase shift, we use the Greek letter phi or phi. You'll hear me say both, but phi or phi, PHI is how you'd spell it in our letters. But in our equation, phi is this circle with a vertical slash through it. And that is how we denote our phase shift or a horizontal shift. And it's just called a phase shift instead of a horizontal shift because trig people are fancy and they like to use different words for basically the same thing. Now, it's important to remember there's two different ways of writing this. So very similar. All of the same letters are here, except that one has omega factored out. If omega is not factored out and it is sine of omega x minus phi, then you're going to use phi over omega. So you have to divide this to find the correct horizontal shift before you do anything else. If it's already factored out, then phi over omega is already here, and you get to use that as is. Remember, we are subtracting is moving right. If you're adding, you're moving left because you're subtracting a negative. But all those things are coming from basically the same idea. This is a two-part lesson. Tomorrow you'll have the last portion, which is the vertical shift. Vertical shift, this is the part that I wanted to talk about briefly, is adding outside of the trig function. So this whole thing is one function plus a constant. That constant moves everything up or down, and this constant is the midline. So if you ever need to find the midline based off of the equation, the midline is just whatever you're adding or subtracting outside of the sine function. Also, quick note, these rules apply for cosine as well. They do not apply to tangent or cotangent because the period is different. So you just have to adjust it a little bit, but everything else should be pretty much the same thing. Just tangent and cotangent is a little different. All right, graphing these things. 3 is our amplitude. So amp, and I just write all these things out so I don't have to think about them later. But amplitude, our starting position is going to be 0, 0. So you might start 0, 0 because it's sine. And then this starting position will get adjusted a little bit because of our phase shift, but we can still find everything else out. So I'm going to factor out that 2. I don't want that. Factor out that 2. So x, and then we have plus pi over 8. Basically just divide pi over 4 by omega. Omega affects our period, so the period is 2 pi divided by omega, which is just pi. Okay, so if you had a fancy whiteboard like I do, then you could graph this right now, and then just shift it, whatever. It's going to be negative pi over 8, but you could just shift it from there. But I want to show that basically it's the same thing, just finding out the new starting position based off this. So the new starting position, everything gets shifted to the left pi over 8. So now we're starting at 0, nope, bad start, at negative pi over 8, 0. So everything got shifted to the left. Doesn't affect the y value, it's a left shift. So the period, remember, is the distance between, or it's the interval it takes to start repeating itself. It's not, for this reason, it can get a little jumbled, so we're not going to actually hit pi comma 0 because everything gets shifted. If 0, 0 was our true starting position, then it would hit pi 0. But you don't have that luxury at this point. I'm going to make my scale pi over 8. So this is pi over 8, pi over 4, pi over 2, 1, 2, 3, 4, 5, 6, 7, 8. This is pi. This coordinate right here. This would be negative pi over 8, our starting position. And that's the reason why I'm doing it this way. You'll see in the next one that I'll probably make it a little simpler. But our amplitude is 3, so make sure you have 3 on there. You can change your scale a little bit, but I'm going to use it this way. And we are going to fit a full cycle in pi units. So from here, this is not pi units. This would be pi plus 8 units. Back it up 1. So we need to fit full cycle into this chunk. So I know that I need to start repeating myself again right there. Halfway through is right here. So this is going to be our 0, and then halfway between here, we're going to have our maximum and our minimum. And again, the nice part with this is that if you're stuck, you can always start plugging in points and see where you're at. But it should look something like that, which is a full cycle. You can graph a few more just to fill out your graph, but you basically have the answer within that first cycle. Get a little wonky, but it'll work. So there you have it. That's the graph. Again, careful with the phase shift. The phase shift is after that 2 has been factored out. Do not move pi over 4 left. It's pi over 8 left. And again, you could always just plug in points to figure out if you're on the right track or not. All right, so same rules apply to cosine. This is cosine instead, so our starting position would have been 0, 1. It'll get shifted a little bit, but we'll figure that out in a second. The amplitude is 2. Our period is 2 pi divided by 4, which is pi over 2. And then our phi is going to be 3 pi over 4. Or factor out the 4 and you have that. So we're getting moved to the left 3 pi over 4. And for that reason, I'm going to have pi over 4 be our scale. So each one of these is pi over 4. This would be pi. 1, 2, 3, 4. Nope. I am going. Yeah, I might have to. Okay, let's just go with it. right now I'm thinking about how these aren't matching up the way I want it to. Yep. Okay. All right, let's see what happens. So if we do pi here, we want the amplitude. I'm going to call that 2, -2, so 1 to 1 on the RY values. 3 pi over 4 to the right is going to be right here. So our starting position is now 3 pi over 4, comma 2 because of the amplitude. And our period is pi over 2. Pi over 2 is going to be here. So every 2 lines is pi over 2. So 2 lines, pi over 2. We need to finish in here. So it's going to be pretty tight the way I had it. That's the reason why I was hesitant to do this. But kind of don't have a choice at this point. So I don't have nice x-axes the way I have it graphed, but some things you just gotta let go. And I think that's probably good. But every one x hash is gonna be hitting a max or a minimum. So in between those are our x. Ooh, gross. All right, because I've spent enough time on this, I made a mistake on there. These should be down here, all of them. So sorry, super crisp video for sure, but I wasn't paying attention. So just make sure your minimums are actually at -2. Your midlines should be the x-axis, not here. This would be a vertical shift, and our amplitude wouldn't be 2. So hopefully you can get that. If not, then let me know. All right, derive an equation with sine where we have an amplitude of 4, period of pi over 3, phase shift of -3. All right, so we can just piece this together, but since our period is pi over 3 is equal to 2 pi over omega. If we divide by pi over 3 multiplied by omega, we get that it's 2 pi divided by pi over 3, which you can flip and multiply this. The pi's cancel. Omega should be 6. And then from here, omega divided by, phi divided by omega is equal to -3. Okay. 6 is omega. So, sorry, I keep saying that. Yeah. Phi is going to be -18. Or you could just have -3 be phi over omega, and you can just use this version. It's always easier for me to go to this version because it's already factored if you know the phase shift. Multiplying it just puts it back into this mess where you'd have to factor. So from the beginning, I usually go with this, and then if they make me go here, then I'll multiply by omega. But it's up to you on which one you pick on this one. I think my open math is mostly in this form, so you'll have to multiply by omega, but it's a quick calculation. Amplitude's 4, so we don't have to do any figuring out there. So we can just throw it all together. Amplitude is 4. You could have -4, I guess, in this case. Most of the time it'll tell you to pick amplitude, or A is positive. Sine of 6x plus 18, since this is negative. So that's version number 1. Version number 2, which I would have done to begin with normally, is factoring out omega. So 6x plus 3. This is always easier to go to. It's also easier to graph from because it's already factored. But if it asks for either one, it's a quick fix. Just have to multiply or factor it out, and it should be good to go. All right, so that's it for today. Tomorrow we're going to go over the vertical shift and how to find it within a scatter plot. We're going to be looking at scatter plots. But that's all for today, and until next time.